welcome to the OGI webinar, Electrical and Solar Powered TotalArc Burner Management Systems. I'm Chris Posey, the Marketing Manager here at OGI, and joining us today again is OGI R&D Engineer Jim Benzo. Let me mention at the start that if you have questions or comments, please post those in the chat console, which is on the right side of your screen. If it doesn't appear there, there's a little chat bubble. You might see a little icon at the top right side. You can click on that and it should open the chat screen for you. So if you'll post your questions and comments there, Jim will handle those at the end of the webinar. So just a little bit about OGI before we get started talking about burner management systems. OGI has been in business now for more than 30 years. We design, manufacture, sell, and service Terry water bath heaters and quick water direct contact water heaters. It's our mission to design, engineer, and manufacture energy efficient process heaters for the comprehensive industrial process heat market. And that's what brings us here today. So with that, I'm going to go ahead and turn it over to Jim to talk to us about electrical and solar powered TotalArc burner management systems. Take it away, Jim.
Thanks, Chris. Our goal today is to provide some background on different BMS power options to allow you to determine which is the best for your application. Today, we're going to start off by just kind of going over the TotalArc BMS, provide you an overview on that TotalArc BMS, and then actually get into the power options that are available. So the TotalArc BMS is based on the same proven and reliable circuit boards used for the TotalArc relighter. We focus on maintaining a standardized just the standardization of components across the TotalArc platform. So basically, those things that we've built and created reliable TotalArc relighter systems are being brought into and have been brought into the BMS system. Like the TotalArc relighter, the BMS has been tested through its entire temperature range at our facility in a environmental chamber. A single ignition rod, just as it is for the TotalArc, is used for both flame ignition and sensing. The TotalArc BMS is fully adaptable to operate in either a pneumatic or a fully electronic control environment. Operation can be configured in any of actually 3 ways, but I've only shown 2 here. A thermostatic pilot, which is also can be configured to be a standing pilot, or an intermittent pilot. For the TotalArc BMS thermostatic pilot, in the pneumatic feature, the pneumatic safeties are being sensed and monitored by the BMS control system's pressure switch. When proven okay, the BMS will energize the pilot solenoid valve and light the pilot. After the pilot is lit, the main solenoid valve will be energized and the main burner will be cycled on and off depending on the process temperature controller that is downstream of that solenoid valve. The pilot will remain on as long as the pneumatic safeties are satisfied. And if the high bath temperature, for example, if the high bath temperature switch were to trip, the BMS control pressure switch will drop out, and the pilot and the main solenoid valves will close, shutting down the pilot and the main burner. Once the bath cools and the high bath temperature switch or pneumatic controller returns to normal, the pilot will be relit and the main burner will be allowed to operate as necessary. Note that this control configuration, the thermostatic pilot control configuration, is primarily used on smaller heaters where there's a chance that the pilot could overheat the bath. For the TotalArc BMS intermittent pilot in a pneumatic configuration, the pilot will cycle on and off with the main burner when the heater safeties are okay and there's a call for heat is present. Again, in this case, we're relocating that BMS control pressure switch, and it's located after the pneumatic safeties and the pneumatic temperature controls. When the safeties are proven okay And when a call for heat is received, the BMS will energize the pilot solenoid valve and light the pilot. After the pilot is proven, and the main solenoid will be energized and the main burner will be lit. When the call for heat for the heater pneumatic safety is lost, the BMS control pressure switch will drop out in the pilot and main burner solenoids will be closed, shutting down the pilot and the main burner, just as we did in the previous version. Once again, though, when the bath cools, in this case, instead of just lighting the pilot, it will actually light the pilot and the main burner under an intermittent operation. So the significant difference between the two is the fact that the intermittent pilot means that the pilot is only on when there's a call for heat. In the case of the standing or the thermostatic pilot, that pilot will remain on until a bath temperature condition is such that it actually shuts down the pilot because of the possibility of overheating the bath. As noted here, the intermittent pilot is something that's can be designed for mid and larger heaters that will not overheat with a pilot configuration. In an electronic version of the BMS, all electronic safeties are wired in series into a single safety input. Loss of any of these safeties will cause the BMS lockout and require a local reset. Common heater safety inputs include the low water level switch, the high bath temperature switch, which we've also shown here, an optional high process temperature, and also an optional high stack temperature. The pilot can be set up for either intermittent or thermostatic / standing pilot based systems, and the configuration between whether it's thermostatic or intermittent is simply set up through a jumper that's in the control panel for the BMS. For the TotalArc BMS thermostatic pilot, when the heater inputs are okay and the BMS is reset, the pilot will be lit using its own temperature bath temperature controller. This bath temperature controller is typically set at a temperature between the normal bath temperature and the bath high temperature shutdown. This allows the pilot to operate as long as possible without a safety lockout to occur. So this way we were able to actually maintain a semi-standard or standing pilot configuration until such time that bath temperature gets so high that we could potentially start boiling off some water or bath media. After the pilot is lit in this condition where the bath is cool enough and there's a request for the safeties are met, the main burner will cycle on and off depending on the process or the bath electronic temperature controllers, which define the call for heat condition. The pilot will remain on as long as the heater safeties are okay and the pilot bath temperature controller set point is not exceeded. Again, the control configuration is focused on smaller heaters, as we've discussed in the past, in the previous version. And note that any condition, if the pilot is lost and the BMS will shut down and the main burner and the pilot will be shut down, and the BMS will perform a 5-minute post purge and attempt to relight the pilot. In an intermittent pilot configuration, the standard BMS features remain the same. We're still looking at the same BMS safety hardwired limits that are all wired in series, and it will cause a lockout. We're still looking at a loss of pilot after a pilot is proven will cause the main burner and the pilot to shut down and a 5-minute post purge to occur prior to relight. So essentially, the BMS really sees no difference between the two. It's just the way that the pilot is being again controlled. in the intermittent pilot mode, as it was for the pneumatic control configuration, when a call for heat signal is received, the pilot will light and be proven, and then the main burner will be lit. And this is all based on the call for heat condition versus just a standing pilot and the main burner coming on with a call for heat. Note that call for heat signal will vary depending on whether or not whether the heater includes both the bath and the process temperature controllers for this condition. Now that we've familiarized ourselves with the BMS operation, let's take a closer look at what options are available for to power our BMS system. The BMS operates the BMS primary operation, or the operating voltage of our BMS, is 12 volts DC, which provides the power for the solenoid valves, the relays, the ignition module. The BMS power supply options provided for all hardware necessary, basically all hardware that's necessary to convert the power from the supply voltage being supplied by the customer or as a part of the BMS package. All that power conversion is handled within the BMS itself. All options are rated for Class 1 Division 2 and will require the customer to comply with hazardous wiring methods when interconnecting to the BMS. Customer supplied options. When a customer is supplying power to the BMS, the power must be clean, free of noise. Must be provided with an overcurrent protection device, whether it's a fuse or a circuit breaker or something. The power must be able to be isolated. So whether it's a disconnect or a switch, or like I said, a circuit breaker, something where power can be positively removed from the BMS system. And finally, it must be well grounded. The principle of the operation is primarily based on sensing flame relative to a ground potential. So if we have poor grounds, any BMS system like ours would potentially have issues. The power source selected will impact the ability for the BMS to support itself when primary power is lost. So basically the longevity of that loss of power and how long that BMS can continue to operate normally without the primary power being available. And also the customer field interconnections required will also vary based on the specific BMS power source selected. So first I'd like to dig into the 120 volt BMS option. Again, it's all AC and DC all AC to DC power conversion equipment is housed within the BMS panel. For the 120 volt version, the client will be required to supply a 2-wire with ground service. In this case, 120 volts AC, 60 hertz, with 10 amps overcurrent protection. In other words, we'll need at least 10 amps available to the unit to allow it to operate properly. Okay, in this case, for the 120 volt version, the UPS system is supplied with the 120 volt version provides an onboard UPS system that actually has its own battery, a separate battery supply up to 10 hours of uninterrupted power if the primary power is lost. Note that this power option is intended for short intermittent power interruptions and not for long-term power loss. If additional duration is required, the customer may want to consider adding or utilizing a UPS supported 120 volt supply to the BMS as an added feature or an added protection to ensuring that the BMS is never going to lose power. As I said, that it actually it has an onboard, in this case, 2.6 amp hour battery that's actually being charged by the UPS system from the 120 volt supply. And whenever that would be lost, we would have up to 10 hours of backup available. For the 12 volt battery with solar package, this is the only option that's fully autonomous. In other words, essentially, no external power is required to support this control system, the BMS. It essentially, its primary power source is a 90 plus amp hour battery, 12 volt DC, that is charged. It's housed in its own separate battery enclosure that is separate from the main BMS system, and in it itself, with that battery being available to the BMS, once we would lose any kind of solar backup at all, we would be able to support full BMS operation for 7 to 10 days. Backup power for the battery and the charging for the battery is provided through a solar panel. It's a 50-watt solar panel and a power converter that transforms that power or the voltage from the solar panel to the battery to keep it charged. To get the best performance out of the solar panel, ensure the panel is facing the southern sky. Adjust the angle of that solar panel based on the latitude of the site, which we're showing here. It's also the same chart and information is provided in the BMS manual. We also want to make sure that panel is clean. Just by the fact that we've installed it and facing the southern sky, we got the right angle. But if it's got snow or any kind of debris that's on it that's blocking any performance, the actual performance of that solar panel will be degraded. A properly positioned, maintained solar panel will provide about 14 to 17 DC volts to the power converter. And note that I think one of the most important parts of this is that you've invested in a solar powered system. The thing that needs to be looked at is that the site installation must consider the fact that if you have tall trees or if you have a tall building adjacent to the heater, you may actually be blocking the source of power that you're using to support that BMS system. So selection of this system would definitely have to be considered if you're in a heavily wooded area where that BMS or heater would be located. You may have to look at another option. When solar panels are required for the BMS system, OGI will ensure that the heaters are equipped with supports and braces to allow the solar panel to be mounted and positioned as necessary. I've shown two different versions here. One is one that for a larger heater that you might see that where the solar panel is supported off the heater shell. And the one on the right here is the heater is supported off the heater leg with another support off the shell just to add stability. The one on the right is something we would typically see for a smaller heater. And of course, like I said, the one on the left you might see for a larger heater or multiple panels on a larger heater. Both are intended to allow the heater's solar panels to be rotated 360 degrees to allow them to face the southern sky. Also that these are provided so that or installed such that there's at least 7 foot of clearance between grade and the bottom of the solar panel. So that way we avoid any potential headaches that could be associated, actual headaches associated with operating these solar panels. The last option that we have associated with power options is the 12 to 24 volt powered BMS. Now this again is something that the customer is providing this power. And in this case, again, we're looking at the customer to provide a 2-wire 12 to 24 volt DC power system with ground to the terminals within the BMS panel. Again, they need to be isolated. And in this case, instead of it being a 10 amp service, we're looking only for 5 amps. Again, since this system this power option does not provide an onboard battery backup or a UPS, the customer will be required to provide a UPS supported DC as power supply to the BMS. This power option is typically selected when installed at a customer's gate station where the electronics are powered by its own 12 volt or 24 volt DC UPS supported power. So it becomes easy just to add the small amount of power that's required of the BMS right off the gate station's RTU system. In this case, as we talked before, that if there's a variation in power that comes to the BMS system, that all power conversion is available or provided within the BMS system. Here's another good example of this. We have a power converter that's actually able to take a variation in power from 10.5 volts to 32 volts and actually maintain a consistent 12 volt DC output. If the voltage were to fall below that 10.5 or exceed that, obviously we'd have safety factors there that would actually would shut down the unit. Anyway, at this point, it really provides a wide variation on what's available for you. Just in summary, these three versions of the TotalArc Relighter are set up to suit or to fit most customers' power requirements. Again, for the 120 volt system, it does require 120 volts AC powered from the customer's facility. As I stated here, it's intended to be more of an intermittent power loss. It's not a long-term power loss system. It does have an onboard UPS system and a battery charger for its UPS augmented battery supply that allows that BMS to operate for 10 hours in the event that we lose primary power. For the 12 volt DC battery system with solar backup, this is fully autonomous. We have quite a few of these in the field, and they really hold up well in all environments that we've been exposed to. It has its own 12 volt DC battery mounted in a separate enclosure. It does have its own battery charger that's supported by a solar panel, and it has that internal charger that's inside the actual battery enclosure. And in this case, as we discussed, it has 7 to 10 days worth of autonomous operation in the event that you either lose the solar panel or well, that would be it. And then finally, it's the DC power operation where we can take either 12 or 24 volts DC from the facility's power. And at this point, though, backup power for that primary power source would be provided by the customer. So at this point, that summarizes our power options that are available on the BMS. If you have any questions, please let us know.
All right, thanks, Jim. As Jim mentioned, if you have questions, you can still post those over on the right side in the chat console. We do want to thank everyone for joining us today. A word about next month's webinar. It will be the last Wednesday in the month of September, and we're switching gears a little bit. We've been doing quite a bit, focusing on carries and TotalArc. So next month we're going to go to one of our other products, the Quick Water, as we prepare to attend Pack Expo Chicago. So next month's title will be Sanitization and Production in the Food and Beverage Industry. And again, that is going to be all about our quick water direct contact water heater. So in the meantime, you can view all of our webinars. I'll post this one on our website today, and I will distribute it also to registrants via email. So you can watch it on demand, this or any of the other webinars that we've put on. Also, I'd encourage you to follow OGI on social media. We're on Facebook, Instagram, Twitter, and LinkedIn. We also have a YouTube page. You can watch those videos on our media page. So follow us and stay in the know about upcoming webinars, events, and just what's going on here at OGI. So with that, we'll go ahead and conclude, and we will see you next month, last Wednesday of September. Thanks for joining us today.